Hi there, yet another video from me, biology video this time. Should only be a short video this time actually, on sampling techniques. Right, now this was a topic you have actually been introduced to briefly in topic 2.1 actually, which was strictly a first year topic. Now we're on topic 1.5, which is a second year topic. We go into it in far more detail though. When we did topic 2.1 we only looked at random quadrats. This time in topic 1.5 we've got to revisit random quadrats, look at it in slightly more detail, but also compare it with the other sampling technique, which is transects. I had originally sort of left this topic out as I just wasn't quite sure if we'd get a chance to do any practical work on this this year. But for biology, it's going to be simply impossible to get all the students in, I'm afraid. There's actually just too many of you to make it practical to get all the biology students in and sort of stay within the limits of the capacity of the college at this time. So you probably will get to do a practical base around this in the second year, but for now we'll just introduce it theoretically. Right, let's start by just introducing the topic of random quadrats, revisiting it, I should say. Now, you would use random quadrats if you just want to sample a single habitat and just investigate the abundance of different organisms in that habitat. You'd only use random quadrats either for plants or for stationary animals. Stationary animals, are there any? Yep. Rocky shores are very common places where you find stationary animals, at least they're stationary whilst they're exposed to the air. Some of them, like barnacles, are stationary all the time. Actually, others, like limpets, when they're exposed to the air. But let's say we're dealing with plants for now. You might simply want to investigate the abundance of plants in this field. Sometimes you just sample a single habitat. Sometimes, though, you'd still use random quadrats to compare two different habitats. You might, for example, want to compare this field at the bottom of a hill with this field at the top of the hill, and you call this field A and field B, and you would sample them both in order to see if there's a significant difference between them. You might even choose to sample one field on this side of the hill, another field on the other side of the hill, see if it makes any difference. Either way, these are what we call uniform habitats. There's no real reason to think that this part of the field is different to that part of the field or whatever. You're sampling a uniform habitat. And when sampling a uniform habitat, it's very important that you sample it randomly. It's also important that you sample it, of course. What you don't want to do is go around the entire field counting every single plant present. It just take far too long. So we have to sample that field. And to sample it, you place quadrats as shown there. But it's got to be a representative sample, of course, in order to make your results reliable. You can't just plonk down one quadrat in each field. You must place a minimum of 10 quadrats to get a representative sample and therefore reliable results. And you must place those quadrats at random positions. So what you usually do is you get a pair of tape measures, mark out a field or part of the field using the tape measures, and you can therefore sort of give it an imaginary grid, that field, and use that to place your quadrats. Just to make sure your quadrats are placed at random, you usually use random number tables, and you would just say, right, first quadrat at 8, 0, second quadrat at 9, 4, third at 2, 5, and so on. Must place at least 10 quadrats. 10 quadrats would allow you to sample 10% of this area, actually, which is considered sort of, a representative sample. If you're going to sample 10% of it, you really want to be looking for around 10% to ensure it's representative. And as I say, if your first coordinate was 8, 0, you'd simply place the quadrat there. But when you place your quadrat, what do you actually measure? Do you go around counting every individual organism? Well, you do for some. It depends what organisms you're dealing with, to be honest. If, for example, you were just sampling the number of dandelions and you weren't bothered, say dandelions and daisies, and you weren't bothered about the grass, you could just count the numbers of them. But if we're including grass, and for many other organisms, it's often far more convenient and time-saving to measure what we call the percentage cover of each species. Now, however, I don't want you just being sloppy and having a quick look and saying, it looks to me like grass is about 75, let's note that down. No, there's a few daisies here and there, let's give them, 5% showing? No. We try to make our results as accurate as possible by subdividing the quadrats. This one, 5 by 5, so 25 squares. Each mini square is worth, say, 4%, and you would go through them saying, right, grass, all of that 4% is grass, all of that 4% is grass, virtually all of that. So that's already 16% grass. Well, there's a bit of a daisy. Maybe that's taken up one of that 4%. So using this column, we might say 19% grass, 1% daisies, and so on, like that. You're not always lucky enough to get divided quadrats like that. Sometimes you might get cruder quadrats like this, just divided into 4, but it's still better than nothing. Again, you don't just look at that and say, what's that? About 80% grass, 20% bare ground, that'll do. Sometimes you record bare ground as percentages. No, you at least use this and say, right, the whole of that 25% is grass just about. Might be a tiny bit of bare ground there. Let's call it 24 grass. This one though, wait a minute. Of this 25%, the top half is all grass, but the bottom half, about a third of it, is bare ground. So let's say sort of 1/6 of the square is bare ground. That's 4 of the 25 is bare ground. So let's say 21% grass, 4% bare ground from that. Add it to the 24% grass from there. So far got 45% grass, and go on with those. Even if you just get quadrat that's not divided at all, you can still sort of mentally subdivide it and say, right, let's look at this quarter first, what's in that. Anyway, you get the idea. What you must do is make an effort to make sure your percentage covers are as accurate as possible, because whilst percentage cover does save us a lot of time, it can of course be a little less accurate than counting individuals, so you must make it as accurate as you can. So, in the end, for say field A, you might have designed a results table like this. You've got to place 10 quadrats, you work out the coordinates beforehand, record the percentage cover for each, you do it in each of the 10 quadrats, work out a mean, and you compare that with area B. It's often what we use random quadrats for, either to simply sample a single area or to compare one area with another. And that is, let me emphasise, random sampling. Sometimes, however, you do not want your sampling to be random. You want it to be totally unrandom. Unrandom is not very good English, is it? Systematic, a much better word to use. Systematic sampling is what we use when we're sort of investigating what is sometimes called non-uniform habitats. But to explain that more clearly, really when we're looking for whether there is a change in the distribution of organisms due to a change in the habitat we are investigating. A classic one that you could do is sampling a rocky shore down near the seafront. The closer it is, the more time underwater this area spends. This could be at low tide, presumably at the moment, and it could at high tide. Maybe the water level reaches up to there, but this part around here might be submerged underwater for 90% of the time. This part about 50%. Up here it might only be submerged for 10% of the time. Does that cause a difference in the distribution? It's a non-uniform habitat where there is a definite change from one end to another. Another classic case of doing this is as you move away from a hedgerow in a field. As you move away, of course, it gets more and more sun, less and less shade. Does that change things? So for systematic sampling like this across a non-uniform habitat, we use a transect. The most common transect we use is a belt transect, where you simply place a tape measure down and place, this could be on a rocky shore, your quadrats at say 0 meters, 2 meters, 4 meters, 6 meters and so on, just to see how it changes. And what you're sampling is a belt of land like that. The idea of the belt is perhaps shown more clearly in that image. Occasionally, instead of a belt transect, you simply do a line transect where you just lay a tape measure down, but you don't place any quadrats next to the tape measure. You just record either the numbers of each individual species of plant touching the tape measure or the percentage at each length of the tape measure. So you might record the percentage touching the tape measure in the first metre from 0 to 1 metres, and it could be recorded as something like this, where in that first metre maybe it's about 2/3 daisies, 1/3 poppies, whatever they are, whereas in the second metre might be say about 20% dog violets, let's say, and the other 80% is grass and so on. So but here you're only sampling a line of the habitat. You only literally record what is touching the tape measure instead of a belt of habitat there where you lay your tape measure down but you place quadrats at regular intervals. Again, note there's nothing random about this placement, it's systematic placement. Sometimes you place your quadrat at 0 meters, 1 meters, 2 meters, and you don't even leave any gaps. Sometimes you might do it like this and go 0 meters, 2 meters, 4 meters. Again, that's showing a line transect. You're only recording what's directly touching the tape measure. Important when you do transects, by the way, to do at least 3 of them. If you simply just lay down one tape measure, whether it's a line or a belt, again, it might just be an unrepresentative part of the shore that your transect happens to go down. So you should sample along at least 3 transects. Again, that's shown there. That would be 3 belt transects shown there. What it would look like if you're doing it coming away from, say, a hedgerow. You should do at least 3 transects again. This little diagram neatly summarises the difference between a line and a belt transect. So, just as one very quick example of a study you might do, does, say in a meadow next to a woodland, does the distribution of foxgloves and grass change as you move away from the woodland? You might have a theory that says foxgloves often found in fairly shady conditions. They're fairly shade tolerant plants. As you move away from the forest edge, will the percentage of the abundance of foxgloves go down and the abundance of grass go up? Well, you'd produce a table like this, maybe just sampling over short 6 metre length of section, and your first transect you might sample at 0, 1, 2, maybe no gaps in your transect, and just record grass and foxgloves in each one. Sometimes you might have more than 2 species in your transect, but again you must lay down at least 3 transects and calculate a mean for each one, and then you'd look at whether actually the percentage of grass is going up and foxgloves is going down or not. Right, that's just about it. I did say it'd be a short video. All I want you to do in terms of written work is on your note sheet, this bit on sampling techniques, the random quadrats and the transects part. For this bit on the random quadrats, a diagram showing the grid and random placement, you could look it up for yourself on Google, or you could just do a sketch of something like this. You could pause this video at this point and sketch what's shown here if you like. And there, diagrams show the difference between belt and line transects. Again, you can either Google it or, again, just use this diagram if you like. Right, once you've done that bit of the note sheet on random quadrats and transects, you can then go ahead and just do section B on the 1.5 question sheet. That's only 3 questions, won't take you very long either. I sent you an email yesterday actually regarding Zoom meetings because we're unable to get all the biologists into college. We thought we should at least provide you with some virtual face-to-face contact and give you sort of 3 Zoom meetings. Now, these are not compulsory. If you feel that you've been following all the work that's been set, understanding it perfectly well, and have no need to take part in a Zoom meeting, you don't have to. I'm not taking a register of who is attending, but it's probably a good idea. It'd be nice to see if you want to attend. First session is on Wednesday of this week. It says 1 till 2 there, to be honest. I should think half an hour will be enough. All that will happen in the session is I'll give you a quick recap of some of the main points at first. It'll just be me talking, but then I'll open up the floor to any questions that you've got. So what I'd like you to do is have a quick review of that topic there, classification and biodiversity. That was topic 2.1. Well worth just having a quick look back over the note sheet for that topic. Question sheet as well would be an idea, and just identifying if there was anything that you didn't understand that you want to ask questions about. So come to that meeting with a list of questions that you want to ask if you have any. But if you don't come up with any questions, just having a quick review of the topic before the meeting would be useful. So you can have a quick look through that. I've sent you the video links to the videos I'd previously made on this topic, which you could sort of skim through those videos, maybe just parts of them again. But as I've sent you very little work today, I will set you more work later in the week, by the way, on succession. But something else I want to remind you of, something I'm sort of not necessarily being brilliant at reminding you about over the year, is this directed study activities. I gave you a reminder of this before Easter, actually, about how you could be catching up with some of those. But since we've been starting topic 1. So sort of 2.1 and 1.5 post-Easter, there's a few more that you could do. You can open the document from Moodle as shown there, and just go down to the post-Easter part, and as you may not have done any of these really up this week. We should be on this one. We don't try to do them all at once. As we're having the Zoom meeting on topic 2.1, it may well be worth just doing the ones that relate to topic 2.1 over the next day or so, going through those things there. So I'll get my thumb out of the way. If you've already been making some summary notes on some of this, you don't necessarily need to do it all, but those are useful activities to be getting on with. And as some of them refer to the textbook, just a reminder, you've got the A1 textbook available there as well. So again, as I've set you very little work right now, please go and sort of have a review of topic 2.1 and do those directed study activities ahead of Wednesday's meeting, please. Okay, that will do for now. Bye everyone.